Hello everyone, welcome to the solution of LeetCode problem 19 named remove nth node from end of the list. Here we are given a linked list and we have to remove the nth node from the end of the list and return the head. Now let's understand the first example. Here the list contains 5 elements, which is 1, 2, 3, 4 and 5. Now we have to remove the second element from the last. So we have to remove the element 4. Now, if we remove the element 4, the link between 3 and 4 will be abolished and the link between 3 and 5 will be established. So 3 and 5 will be connected here. And it is the modified linked list, which is 1, 2, 3 and 5. Here, the 4 is removed. I hope you understood the problem statement. Now let's move on to the algorithm. Now, to understand the algorithm, let's take this example here. The linked list contains 6 elements from 1 to 6. Suppose the value of n is 2. That means we have to remove the second last element from end of the list. So here the second last element is 5. So we have to remove it and discard this link as well and establish the link between 4 and 6. And this is the modified linked list. Now, how can I solve this problem? Here, we can simply solve this problem by using the 2 pointers mechanism. One is slow pointer, another is first pointer. But before jumping into the pointer approach, let's understand some of the edge case. It can be possible that our linked list can contains only one element. So if our linked list contains one element, we have to return null. Because if our linked list contains one element, we have to remove this one element and the linked list will become empty. So we have to return null. This is the one test case. Now, let's take 2 pointers. One is slow, which is S, and another is first, which is F. Now, both of the slow and first pointer initially points to the first element or the head to the linked list. Now, let's shift the first pointer by the value of n into the right side. So here the value of n is 2. So we have to shift the first pointer 1 unit and another unit. Now our first pointer is pointing here. Wait. Suppose let's take another edge case. Here the linked list contains 6 elements. So here it can be possible that the value of n will be 6. That means we have to remove the 6 element from the end. That means we have to remove the first element. Now, in this case, the F will be moved 6 unit to the right. 1 unit here, 2 unit, 3 unit, 4, 5, and 6. Now, if the value of n is exactly equal to the size of the linked list, the first pointer will pointing to the null. And if this is the case, we have to remove the first element of the linked list. So we have to return head of next. It is another test case. So we have found 2 of the test case. One is if linked list contains one element, and another is if the value of n is equal to the size of the linked list. And if the value of n equal to the size of the linked list, we have to discard the first element of the linked list and simply return the head of next. I hope you understood these 2 edge case. Now let's see how can we solve this problem by using the slow and first pointer. Now, suppose the value of n is 2. Initially, our slow and first will pointing to the first element 1. Now, first will be shifted 2 units into the right. So first is here. Now, our slow is pointing to first element and first is pointing to the element 3. So now we will move these 2 elements until first does not have any other next element. here we have to shift 1 unit right to the slow pointer and shift 1 unit right fast pointer. Again, we have to shift 1 unit right slow pointer. Again, 1 unit right fast pointer. Again, 1 unit slow pointer, and again 1 unit first the first pointer. Okay, so far so good. Now our slow pointer is pointing to this element 4 and first is pointing to this element 6. Now we cannot move further the first pointer because the next element is null. So here, so far so good. Now for the n equal to 2, we have to remove this element. So here our slow pointer is pointing to the previous element of the desired removed element. So we have to simply discard this link and establish a link between 4 and 6. After that, this portion of the node will be removed. And this is how we utilize the 2 pointers approach, which is slow and fast pointer, to solve this problem. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named remove and from end, which is a linked list as a parameter and the value n. Now it can be possible that a linked list contains only one element. In this case, we have to return null because we have to remove this single element for sure. Now we are taking 2 pointers, which is slow and first. Initially, both of them is pointing to the head. Now we are shifting the first pointer by n times. Now it can be possible that first pointer is pointing to null. That means the value of n is equal to the size of the linked list. Here we have to simply return head of next. It is the second edge case. Now we have to shift the right pointer till we did not find any of the next element and repetitively shift the slow and fast pointer to the next pointer. Now, if the loop is over, our slow pointer is standing the right before element of the desired removed element. So the slow pointer of next will be slow pointer of next of next. That means we are establishing the connection between the previous and next element of the desired output or the desired removed element. Finally, we have to return the head. I hope you understood the code. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.